Today we'll discuss nodal analysis. So in yesterday we have discussed mesh analysis. In mesh analysis, KCL or KVL is applied. Which one is applied?
KVL.
KVL. Algebraic sum of voltage drops in a loop is equal to 0. But in mesh nodal analysis, we'll apply KCL. In nodal analysis, we'll apply KCL, Kirchhoff's current law. So in mesh analysis, what we have determined? What we have determined in mesh analysis? We have determined loop currents, closed loop currents I1 and I2 in yesterday class. But in nodal analysis, we will determine node voltage in nodal analysis. We will determine node voltage and branch currents. Is it visible?
Blur, sir.
Okay, otherwise I'll switch off the light so that it will be visible. Okay. In mesh analysis, we are determining the loop currents. Today we'll discuss nodal analysis. In nodal analysis, we'll determine node voltage and branch currents. Okay. In mesh analysis, we have applied KVL. In mesh analysis, we have applied KVL. Today we'll discuss nodal analysis. So in nodal analysis, we will apply KVL. Let us take an example. Write down the question. Determine node voltage and branch currents. Determine node voltage and branch currents for the circuit shown in figure. Determine node voltage and branch currents for the circuit shown in figure. Okay, see here. Here in this circuit, how many nodes are there? First of all, what do you mean by node? Anyone? What do you mean by node?
Joining of two or more branches.
Joining of two or more branches.
At the common point.
Okay.
Sir, your video is off.
Sorry, see here. Here, node means joining of two or more branches. Branch means in between two nodes will get one line. Here, node means joining of two or more branches, and branch means in between two nodes will have one branch. In between two nodes will have one branch. That is called branch. So in this circuit, how many nodes are there? In this, two nodes. Okay. See here, this is the node. This is also a node point. To this node, this is one branch. In between this node and this node, there is one branch. Here, this is another branch. This is the another branch. Totally three branches are connected to this node. And this node, I am taking it as the reference node. In any circuit, we'll have one reference node. That is called ground node. In any circuit, here two nodes are there. But generally, here I am saying we are having only one node. This is the first node, this is second. Second node I am taking it as ground node. That is called reference node. That is called, that is at the zero potential. Voltage at the ground node is 0 volts. Now here this is one node. We are having only one node in this circuit. Okay. The other one is 0. We are not considering this as the node. So to this node, how many branches are connected? 1, 2, 3. 3 branches are connected. So what is the line? What is the branch? This is one branch. Branch means in between two nodes connecting one line. This is one line connected in between these. This is the second line. This is the third line. Totally three branches are there and one single node is there. Single node, let us assume that voltage of this node is V1. Now I have to determine node voltage and branch current for this circuit. So voltage at this node is V1. Let us assume voltage at that node point is V1. Okay. Write down node, sorry, write down node point. Assume all currents are leaving from the node point. Assume all currents are leaving from the node point. Assume all currents are leaving from the node point. For determining node voltage, V1. Assume all currents are leaving from the node point. For determining node voltage V1. So this is the assumption. What I am assuming is three branches are connected. 1, 2, 3. So I am assuming the current in this is this one. Let us assume three currents. This is I1, I2, and I2. Assume this current is leaving from the node point outside. It is moving outside. This current is also moving outside from the node. This current is also moving outside from the node. All the arrows are outside, not inside. In the first class, I had told KCL. If current is leaving from the node point, what will take? Positive or negative sign?
Positive.
Positive. If current is leaving from the node, we will take positive. If current is entering, we will take minus. But here, our assumption is all currents are leaving. Let us say this is I1, this is I2, this is I3. Here, if current is leaving, we will take plus. Our assumption is all currents are leaving. If all currents are leaving, all are plus. Forget about the current directions given in the problem. What I am saying is, for determining node voltage, forget about the current directions given in the problem. We will assume all currents are leaving from the node point. We are not considering the actual direction of current given in the problem. We are following our assumption for determining only node voltage. Please remember, for determining only node voltage, we are assuming the current direction. Now here, first I am taking I1 current. This I1 is flowing like this. If current I1 is flowing like this, V1 is at higher potential, 0 is at lower potential. See, the arrow is like this. Our assumed current direction I1. If our arrow is like this, V1 is at higher potential, 0 is at lower potential. Suppose its current direction is like this. Now 0 is at higher potential, V1 is at the lower potential. Please remember direction. If your current is flowing from V1 to 0, V1 is positive, 0 is negative. One second, one minute. Suppose if current is flowing from 0 to V1, 0 is positive, V1 is negative. Please remember, if current is like this, V1 is positive, 0 is negative. If current is flowing from 0 to V1, 0 is positive, V1 is negative. Now, what is our direction? I1 assumed direction from V1 to 0. So, what is the current formula? I is equal to V by R. I is equal to V by R. Here, current I is equal to V by R. This current is flowing like this. Now, what we will take here? This is I1. In the numerator, we have to take voltages. What are the voltages in this branch? V1. Here, current is flowing from plus to minus. See the direction of this arrow. It is moving from plus to minus. If it is moving from plus to minus, it is plus or minus?
Minus.
Minus. Minus 10 and minus 0. In the numerator, I have written voltages. In the denominator, what is the resistance in this branch?
1.
1 ohm. So this is your I1. So this arrow is complete. V1 is positive, 0 is negative. Okay. Since current I1 is flowing from plus to minus, we are taking minus. So I1 I am writing as V1 minus 10 minus 0 by 1. Now come to I2. Here this arrow is moving from V1 to 0. Our assumed direction is from V1 to 0. V1 is positive, 0 is negative. V1 minus 0. Numerator voltage, denominator resistance. What is the resistance in this branch?
2. 2.
2 ohms. Next come to I3. Where is I3? This is I3. Our assumed direction from V1 to 0. V1 minus 0 by 3. This is your algebraic sum of currents meeting at a node is equal to 0. KCL we are applying. This is your equation. Now I want the node voltage. So V1 I am simplifying this equation. 1 plus 1 by 2 plus 1 by 3. This minus 10 comes to that side. That will be plus 10. Now take LCM. Tell me V1 value. Simplify and tell me value. 60 by 11.
Five 5.45.
How much? 4.5.
5.45.
5.45. This is the node voltage. In this way, we will determine node voltage. For determining node voltage, what we have considered assumption?
All are in direction.
All currents are leaving from the node point. Okay. Now forget about our assumption. Now we will determine the actual value of current I1, I2, and I3. That is given the problem.
Okay.
Hello, sir.
Now forget about the assumed current. We will come to the actual current. See the actual current I1. How I1 is flowing? I1 is flowing from 0 to V1. See the direction of I1. I1 is flowing from 0 to V1. See this direction is flowing like this. Now forget about this direction, assumed direction. This assumed direction is only for determining the node voltage. Once you determine node voltage, there is no necessity of assumption. Now come to the actual direction of that. This I1 is moving from 0 to V1. Now 0 is positive, V1 is negative. Now see the direction 0, positive, 0. Current is flowing like this. From minus to plus. Minus to plus means
Plus.
plus. Now V1 is minus. Because current is flowing from 0 to V1. 0 is positive, V1 is. When you have considered here in this direction, we are getting V1 minus 10 minus 3. And here we are getting 0 plus 10 minus V1. Now what is the resistance in this? 1. This is your actual current I1. Now come to I2. See the direction of I2. It is moving from V1 to 0. V1 minus 0 by 2. Now see I3. I3 is, what is I3?
0 to V1.
0 to V1. That is 0 minus V1 by, you know V1. Substitute V1, you'll get I1, I2, I branch current. Once we determine node voltage, we can easily calculate the branch currents I1, I2, and I3. Any branch current. Note down. If you are having doubt, you can ask me. We'll do the next problem. Second problem. Determine node voltage and branch currents. Determine node voltage and branch currents for the circuit showing figure. So how many nodes are there? How many nodes are there?
1,
One node.
2,
This is the node. Let us assume voltage at this node is V1. Another node is that only one node is there. Now I have to determine this load voltage. For that, what is the assumption?
Current
What is the assumption?
Current
Assume all current leaving from the
node
load
point.
point. Here three branches are connected to this node. This is one branch. Branch means in between two nodes. This is one node, this is another node. In between two nodes, you will get one branch. Here also, in between two nodes, you will get one more branch. Here also one node, one branch. Now first I am writing this current. You know current is equal to V by R. In the numerator, write voltage. V1. V1 is the high potential, 0 low potential. V1 plus 7 or minus 7. V1
Plus.
plus or minus 7.
Plus 7.
7.
plus
Now remember always smaller terminal is negative, bigger terminal is positive terminal. This current is moving from minus to plus. Minus to plus, that's why plus. Here plus to minus. Plus to minus means minus. Minus 0. Divided by resistance in this is 2. One array is completed. We have completed one array. Now come to the second array. Second direction. V1. What is this? V1
minus 8
minus 8 minus 0
minus
divided
by
by 3. Okay. Here what is the value in the denominator? What is the resistance in that branch?
5.
9. Because both are in series. 4 and 5 are in series. In series we add resistance. Numerator voltage, denominator resistance. See, I is equal to voltage by resistance. Voltage by resistance. Voltage by resistance. Voltage by resistance. This is KCL we are applying. Now we have to determine V1. That is V1 1 by 2 plus 1 by 3 plus 1 by 9. 7 minus 6, 1. 1 by 2. 1 by 2 means 0.5. What is 8 by 3? What is 8 by 3 value? 2.66.
2.66
9 by 9. 9 by 9 is 1. That is V1. Take LCM. This is minus 1.5, 2.66. What is this value?
minus 4.1.
Minus 4.1. Okay. If we bring to the right hand side, 4.1. Now take LCM of this and determine V1. Take LCM of this and determine V1. So that we will get V1. Okay.
Two point nine four.
How much? 2 point. What is the value? How much you are getting V1? Anybody got? Okay, we will be getting V1 here. Now see here, what is I1? What is I1? I1 is, now forget about the assumed current. Forget about assumed direction. Now come to the actual direction of current. What is the actual direction of current I1? This is the direction. From 0 to V1.
0 to V1.
0, 0. What
Plus
will get? 0 plus 6
6.
minus 7 minus V1 by I2 is moving from 0 to V1. 0 plus 8 or minus 8? 0 minus to plus means plus 8 minus V1 by 3. Now I3 V1 to 0. V1 is the higher potential, 0 lower potential. If you know V1, you can calculate I1, I2 and I3. In this way, we will determine the node voltage and branch current. Next problem. Determine node voltage and branch currents using nodal analysis. Have you drawn the circuit?
Yes, sir.
How many nodes are there in the circuit?
2.
2 nodes. See here. This is one node V1. This is another node V2. So this branch is connected here. This branch is connected here. This branch is connected here. This branch is connected. All branches are connected to this common point. That's why we are taking it as ground node. Okay. All the branches are connected to one common point, which is taken as the ground node. Now we are having two nodes. We will get two nodal equations. Previously we are having one nodal equation only because we are having only one node. Number of nodes is equal to number of nodal equations. So first node point I am considering. For determining the first node voltage, assume all currents are leaving from the node. So here to this node, three branches are connected. From V1 to 0, here again V1 to 0. But this node, what is this arrow? How this arrow is connected this branch? In between what?
Two nodes.
Between V1 and V2. Branch means between two node points. This is one node, this is another node. In between these two nodes, we will get the branch. This arrow is related to V1 and V2. That means if arrow is moving like this, V1 is at higher potential, V2 is at lower potential. If you are writing the first nodal equation. Now come to the second node, this is the node. Here also how many three branches are connected? Totally three branches are connected. So if we take this node, this arrow, V2 is at higher potential, V1 is at higher potential. In between V2 and V1. When you are considering the first equation, when you consider this arrow, V1 is higher, V2 is lower. If you consider this node, arrow is like this. V2 is positive, V1 is negative. Okay, just reverse. In the first node, V1 positive, V2 negative. In the second node, V2 positive, V1 negative. So this node also 1, 2, 3. Three branches are connected. Now I write the first nodal equation at V1. See three arrows. What is the first arrow? This is the arrow. It is moving from V1 to 0. That is V1 is positive plus 5 minus 4 minus 0 by 1. First arrow is completed. See, if you are having no equation, first arrow is completed. Now come to the second arrow at this node, this one. It is moving down from V1 to 0. That is V1 minus 6 minus 0 by 2. Now tell me the third one. This arrow. Arrow is moving from this node to this node. V1 to V2. V1 is positive, V2 is negative. Now tell me the equation. Yes, what is the value of this voltage? What you will write? Anyone?
V1 minus 7 minus 2. Minus
V2.
2.
Okay. V1 minus 7 minus V2 by, what is the resistance in this branch?
3.
Three arrows are completed. 1, 2, 3. One branch, second branch, third branch. Three branches are completed. Okay. Now simplify this. V1 1 plus 1 by 2 plus 1 by 3. That's V2 minus V2 by 3. 5 minus 4 1 plus 1. 6 by 2 is 3 minus 3 minus 7 by 3. That is 2.33. That is equal to 0. Okay. We have separated V1 terms, V2 terms, and constant terms. Okay. Let us see equation 1. Approach we can simplify this. Just I am writing the equation. Now come to the second node equation. We will write the second node equation now. PM. First take this arrow. This arrow is moving like this. V2 to V1. V2 positive, V1 negative. First case, V1 positive, V2 negative. But second case, arrow is like this. V2, what is right? V2
V2 plus
Positive.
7 minus
plus 7
minus V2.
minus V1 divided by, what is the resistance in this branch?
3.
3. This arrow is over. Now come to this arrow. V2 minus 0 by
4.
4. Next, what you write? This arrow. V2
Minus
Minus 8.
8 V. 8.
V2 minus 8 minus 0 by
5.
5.
is equal to 0. Is it visible? Now similarly here also separate the V1 terms and V2 terms. V1 is minus V1 by 3 plus V2 1 by 3 plus 1 by 4 plus 1 by 5. 7 by 3 is 2.33. 8 by 5. What is 8 by 5?
1.6.
1.6. So now we have got two equations. So we are, how many unknown variables are there here?
2.
2, V1 and V2. So two equations are sufficient to solve the V1 and V2. Don't solve now. It will take so much time. We should know the procedure, how we are solving the problem. In exam, we can easily solve. Calculation part we can do. Now we can determine V1 and V2. We will get V1 and V2 from these two equations. So we are getting, now we know the value of V1 and V2. Now we know V1 and V2. If you know V1 and V2, I can determine the branch currents. See here. Now I1. What is I1? I1 is flowing from like this, 0 to V1. Now what is I1 here now? Now forget about the assumed direction. Now concentrate only on the actual direction of current given the problem. 0, what is it? 0
4.
plus 4
Plus 4.
minus 5.
5.
0 plus 4 minus 5 minus V1 by, sorry, 1. 1. This is your current, first current. That means if you know V1, we'll get I1. If you know V1, we'll get I1. Now come to I2. It is moving upwards. 0 higher potential, V1 lower potential. 0, what is that?
Plus 6.
Plus 6. Zero plus 6 minus V1. What is I3 now? What is I3?
V1 minus 7 minus 1 minus 7.
7.
I3 is flowing from V1 to V2, actual direction. V1 higher potential, V2 lower potential. V1 minus 7 minus V2.
Minus V2.
V2 by, that is your I3. Now we will go for I4. What is I4?
V2 minus 0.
V2 minus 0 by
4.
4.
4. Similarly, I5. What is I5?
0 minus V2 by,
0 plus 8 minus 3. This is your I5. 0 plus 8 minus V2 by 5. If you know V1 and V2 node voltage, we can determine all the branch currents I1, I2, I3, I4, I5. Go through the problem. If you are having doubt, you can ask. Okay. Next, we'll go to the next topic, that is source transformation. Next topic, heading source transformation. Before going to this, already I have told you this is the voltage source. This is voltage source. This is current source. This is voltage source. That is current source. I have told you that current, this is negative terminal, this will be positive terminal. By default, smaller terminal is negative, upper terminal is positive. Current always flows from negative to positive. I don't know. Note, current always flows from negative to positive terminal. Current always flows from negative to positive terminal. Current all, any doubt? Current always flows from negative to positive terminal, like this. From negative to positive, like this, in the upward direction, current will flow. That's why arrow is represented in the upward direction. Suppose if I write like this, what is the direction of current here?
Downwards.
Downwards. You have to represent like this. This is the difference. Current is like this, arrow is in the upward direction. If terminals are like this, from negative to positive, current will in the downward direction. Now write down. All next note point. Always resistance will be in series with voltage source and in parallel with the current source. Write down. Always resistance will be in series with the voltage source. Remember this point. Always resistance will be in series with the voltage source?
So can you tell again clearly?
What is it?
Can you tell again clearly, sir?
Okay.
Voice.
Always resistance will be in series with the voltage source. The voltage for this voltage source resistance will be in series. Always resistance will be in series with the voltage source. But see here in current source, the resistance will be in parallel. Both these are parallel. These two are in series. Always resistance will be in series with voltage source. Always resistance will be in parallel with the current source. If it is voltage source, resistance has to be connected in series. If it is current source, we have to connect the resistance in parallel. These 2 points are very important. Now we will see how to convert the voltage to current source, how to convert the current to voltage. Let us take an example. This is 10 volts. This is 5 volts. Let us take this 10 volts and 5 volts. Now I want to convert the voltage to current source. Now I want to convert 10 volts to current. What is the formula for current?
V
V by R.
V by R.
V by R. Two ampere. Now the whatever you have got here, I am placing here 2 ampere. I am placing 2 ampere. Now what is this resistance? Whatever the resistance that is in series with voltage, the same resistance I will connect in parallel with the current. The resistance should be connected in parallel with the current source. We should not change the resistance. Resistance will be same in both left side and right side circuits. Only the current ampere will change. I is equal to V by R. But resistance has to be connected same. Now we have converted the voltage to current source. Now we will convert current to voltage source. How will we convert? See here, V is equal to I into R. I is to V is equal to I into R. Now 10 volts. Now one thing we have to remember here, see negative to positive. That's why arrow is placed in the upward direction. Suppose if these terminals are interchanged, this arrow will come down. Suppose if we interchange these two terminals, we have to place the arrow in the downward direction. Okay. Now 10 volts. Now 10 volts I am connecting here. Whatever the resistance here, the same resistance I am connecting, 5 volts. In this way, we will convert voltage to current source and current to again voltage. This is called source transformation. In this, what you have to remember is always resistance will be in series with voltage source and in parallel with the current source. Resistance will be in parallel with the current source. If you remember this simple technique, simple logic, we can solve any type of problem. We can simplify any type of network in basic electrical. We will do an example so that you can understand clearly. Write down the question. Convert the entire circuit convert the entire circuit convert the entire circuit into convert the entire circuit into single equivalent voltage source into single equivalent voltage source, single equivalent voltage source and single equivalent resistance and single equivalent resistance. Once again I am telling, convert the entire circuit into single equivalent voltage source and single equivalent resistance, single equivalent voltage source and single equivalent resistance using source transformation, using source transformation. So I want to replace the entire circuit. We should have only one voltage source and one resistance in the entire circuit. Now I have to eliminate the current sources. See here how we are eliminating the current sources. These two are in parallel. What is the voltage? What is the voltage? V is equal to I into R. 6 into 3.
18.
18, sir.
See, I am representing negative and positive because average is upward. Current goes from negative to positive. 18 volts. Now, for the voltage source, resistance should be in series. Which resistance? Whatever we are converting this, that resistance should be in series. Okay, see. Now see here, this 4 ohms as it is I am keeping. 4 volts also as it is I am keeping. Now I have converted this one. 18 and 3. Now I will convert this one. What is the voltage? 16.
16.
See the polarity? Arrow is downwards.
Downwards.
Negative is upward, but here it is upward, negative positive. It is downward. Okay. Now what is the resistance?
2.
2 ohms. That should be in series. Voltage source should be in series. Here also voltage source is in series. After converting the current source, the resistance parallel is coming to series. Here also resistance is coming in series, 2 ohms. Now we are having 3 voltage sources and 3 resistances. But in the problem he is asking there should be only one voltage source and one resistance. Now consider any one direction, either this direction or this direction. Any one direction is considered. I am considering this direction. We will get the same answer. Let us consider this direction. This is the array is moving from minus to plus 18, plus to minus 12. Equivalent voltage minus to plus.
Plus 16.
What is the value?
Sir.
How much?
22.
What is the value? 12 or 22?
22.
22.
22.
Here 3, 4 and 2 are in series. All are in series. In series we will add the resistance.
9.
9 ohms. Now since the V equivalent is positive, It is moving from positive means minus 2 side. Okay. If you contain this arrow, minus 2 plus means positive. 22 volts is positive. 9 volts. This is your equivalent circuit. So we have simplified the network. Now the conclusion is source transformation is used for simplification of the network. Any complicated network can be simplified by using source transformation. Okay, that is the conclusion. In this way, we will apply the source transformation. We can convert voltage to current source and current source to voltage source. Now, let us take resistance in series. Next topic. Studying resistance in series. Studying R1. Let us take R1, R2, R3 are in series. R1, R2, R3 are in series. What is the equivalent resistance?
R1 plus R2.
R2 plus
plus R3.
R1 plus R2 plus R3.
R3.
Now resistance is in parallel. Suppose if R1 and R2 are in parallel, what is the equivalent resistance?
1 by R1 plus 1 by R2 plus
by
1 by
R2.
1 by R equivalent is equal to 1 by
1 by
R1
R1 plus 1 by R2.
1 by R. That is equal to
R1 plus R2 by R1 into R2.
1 plus R2 by.
R1 plus R2 by R1.
Now R equivalent is equal to
R1 R2 by
R1 R2 by R1 plus R2. You have to remember this formula. R1 R2 by R1 plus R2. If two resistances are in parallel, please remember R equivalent is equal to R1 R2 by R1 plus R2, because we use this one in the problems. If two resistances are in parallel, directly I will take R1 R2 by R1 plus R2. From the next class onwards, I won't tell, directly I will use this formula R1 R2 by R1 plus R2. Okay. So I will take the attendance now. Wait for some time. Okay, I have taken the attendance. You can exit now. In the next class, we will see remaining things.
Thank you, sir.